Hi everyone, myself Sheikh Urfan. Today my topic is probability density function PDF. Now, probability density function PDF is a function that shows how probabilities are distributed over possible values of random variable. It tells the probability that the random variable takes a value less than or equals to a certain number. Mathematically, it is expressed as fx of x is equals to p of capital X less than or equals to small x, where capital X is a random variable, x is a real number, and f of x is a probability that x is less than or equals to x. Why is PDF used? To understand the probabilistic behavior of a random variable, it helps to calculate cumulative probabilities, shows how likely it is that outcomes fall within certain ranges. Essentially, for analyzing probability in real world problems like coin tosses, games, measurements, and etc. Where is PDF used? PDF can be used in many places like in probability theory and statistics, in engineering for analyzing signal behaviors, in data science for modeling uncertainties, used in real life situations like number of heads in coin tossing, number of defective items in a batch, measuring continuous qualities like height, temperature, etc. Why do we calculate using PDF? What do we calculate? Use PDF. We calculate cumulative probability up to a certain value, probability of ranges of outcomes, likelihood of occurrence of specific outcomes. For example, tossing three coins. Let's say we toss three fair coins. We define capital X is number of tails shown. Here sample space is total outcomes. 2 cube is 8 outcomes. Here we can show the output. Here x1 equals to 0 for the event no coin shows tails, x2 equals to 1 for the event 1 coin shows tails, x3 equals to 2 for the event 2 coins shows tails, and the final x4 equals to 3 for the event all coins shows tails. Here p of x1 is 1 by 8. In this only one outcome, 3 heads are possible. And next p of x2 equals to 3 by 8. Outcomes are 2 heads and 1 tails. P of x3 is 3 by 8. The outcomes are 2 tails and 1 head. These can be written as in 3 types. And finally P of x4 is 1 by 8, only one outcomes. These are 3 tails. The probability function distribution function can be calculated as fx of x1 is equals to p of capital X less than or equals to small x1. By using this function formula, we can calculate the distribution function. Here x is random variable, p of x is probability of density, and f of x is distribution function. By using the given values, we can plot the values in the graph, and distribution function of graph can be shown like this. Expression for distribution function. In these discrete random variables, a discrete random variable is a variable that takes specific and countable values like 0, 1, 2, and so on. For example, number of heads. When tossing three coins, number of students present in class. What is probability distribution function? F of fx of x. The distribution function fx of x is a cumulative sum of all probabilities of x up to a value x. Since capital X is discrete, fx of x takes the form of staircase. It is in the form of a staircase and it increases in steps. The height means the amplitude of each step is equal to the probability of capital X at the value. Here capital X is a random variable. Mathematical form of a distribution function. If the possible outcomes of capital X are small x1, x2 and so on xn, the functions can be written as fx of x is equals to sigma I equals to 1 to n p of xi into u of x minus xi, where p of xi is a probability that caplex equals to small xi. The caplex is random variable and small xi is the event in a random variable. V of x minus xi is unit step function. Let us know what is unit step function E of x. V of x is 1 if x greater than or equals to 0, 0 if x less than 0. It's a function that helps in activating the probability value only if x greater than or equals to xi. For example, tossing 3 coins. Let's say we toss 3 fair coins. The random variable x is the number of heads. Let the values of x be. Small x1 is 0 and small x2 is 1, small x3 is 2 and x4 is 3. From table 2.1 referred in the screenshot, assume p of x1 is p of 0 is equals to 1 by 8. P of x2 is p of 1. x2 value is 1 and the value of p of 1 is 3 by 8. P of x3 is p of 2. The value of it is 3 by 8. P of x4 is p of 3. The value of it is 1 by 8. Then fx of x is equals to p of x sin x1 into u of x minus x1. By using the given formula, we can substitute the values in the formula. This is the distribution function for the number of heads in 3 tosses. By using this formula, we can calculate and plot the values in the graph. The graph will be in a staircase. On x-axis, number of heads will be shown, and y-axis distribution function will be shown. Continuous random variables. If X is a continuous random variable, the distribution function fx of x is the integration of all continuous probabilities of x up to the value x. Definition of distribution function. Here the definition is, let fx of x be the probability function of x. Here x is a random variable, a continuous random variable. Then the distribution function of X, denoted by fx of x, is a continuous distribution function. The formula can be written as fx of x is equals to integral minus infinity to x fx of t into dt for continuous distribution function. For example, let fx of x is 1 by 12 for 0 less than or equals to x less than or equals to 12. This means that the probability is uniformly distributed between 0 and 12. Then the distribution function fx of x becomes as shown in the figure. Fx of x is integral minus infinity to x fx of t dt is equals to integral minus infinity to x 1 by 12 dt. By simplifying this, now simplify the given figure, given problem. For 0 less than or equals to x less than or equals to 12, fx of x is x by 12. For x greater than or equals to 12, fx of x is 1. By using the values, we can plot the distribution function graph for continuous and discrete functions, and density function of fx of x is a constant horizontal line at 1 by 12 for from x equals to 0 to x equals 12. This means every value in the range 0 to 12 is equally likely. B. Distribution function fx of x. A straight increasing line from 0 to 1 between x equals to 0 and x equals to 12. After x equals to 12, the function stays at 1, meaning total probability is fully accumulated. In the first graph, we can show that the values are from certain ranges, and the second graph we can show that The values are starting from minus infinity to and ends at infinity. Discrete versus continuous probability distribution functions. The difference between discrete distribution function and continuous distribution function is for first features discrete distribution function fx of x, continuous distribution function fx of x, type of random variable, discrete example number of heads in coin toss, for continuous example time, height and weight. Mathematical form for discrete distribution function is fx of x equals to sigma I equals to 1 to n p of xi v of into u of x minus xi. For continuous distribution function, we can write it as fx of x is equals to integral minus infinity to x fx of t dt. And the definition for discrete distribution function is cumulative sum of probabilities up to x, and continuous distribution is cumulative integral of PD of f of x up to x. Nature of the function is in discrete distribution function it is a staircase, means stepwise increase. For continuous it is smooth and continuous curve. Graphical shape, it has many jumps and discrete points. For continuous gradually increase without any points or steps. Thank you.